Hi class. In this lecture here, we're going to talk about something called the law of sines. And so what we're going to work through here is we're going to use the law of sines to solve oblique triangles. If you forgot what oblique triangles are, that's okay. I'll define it in a second. We're going to use the law of sines to solve, if possible, the triangle or triangles in the ambiguous case. I will, have two examples of that. That's a little bit confusing. And then I'm going to introduce a formula that we're talking about how you can find the area of an oblique triangle using the sine function. And then the last thing we're going to do a fun application problem. So I'm going to talk about how you solve applied problems using the law of sines. Okay. So what is an oblique triangle? So an oblique triangle is a triangle that does not contain a right angle. So I have two pictures here. You can see that neither one of these have a right angle. So an oblique triangle has either three acute angles. So right here, this is three acute angles. Okay. Or two acute angles and one obtuse angle, okay? And just always recall, right? Like if you forgot, the sum of the interior angles must be 180 degrees. Just don't forget that. Okay? And so it turns out the relationship among the sides and the angles of right triangles defined by the trigonometric functions, you can't use them for these. They're not valid for oblique triangles. So we're going to need something different here. Okay, so what you'll see in the coming slides here is the capital letters represent the angles. So this is angle A, this is angle B, this is angle C. And the lowercase letters, lowercase a, is the length of the side opposite the angle. Excuse me. So same thing for C and B. Also over here too. All right. So what our law of sines tells us then is the following. If capital A, capital B, capital C are the measures of the angles of a triangle, and lowercase a, lowercase b, and lowercase c are the lengths of the sides opposite these angles, then the following. Okay, you have these ratios here. A divided by sine of capital A is equivalent to B divided by sine of capital B, which is also equivalent to C divided by sine of C. And you can use any of these equations in pairs. Okay, use any of these equations in pairs. So we will use these equations in pairs. Or this statement here in pairs. So what for example, I could do something like this. A divided by sine of A is equal to C divided by sine of C. Or I could do something like this. B divided by sine of B is equal to C divided by sine of C. So we're going to use these in pairs. Okay, and they're going to help us solve for missing values. Okay. So basically the ratio of the length of the side of any triangle to the sine of the angle opposite the side is the same for all three sides of the triangle. Always, always, always. Okay, so solving an oblique triangle means finding the lengths of its sides and the measurements of its angles. So we're going to want to find, so going back here, we're going to find what the value of angles A, B, and C, and then the values of all the sides, A, B, and C. That's what it means to solve it. All right. So the law of sines can be used to solve a triangle in which one side and two angles are known. Okay. So you're going to need to know one side, two angles. One side, two angles. Okay. So the three known measurements can be abbreviated as side angle angle or angle side angle. Okay. There's a case then we'll talk about something called the ambiguous case where you're given side side angle. Okay. All right. Okay, I'll spend a lot of time talking about this ambiguous case here. All right, so let's do an example here. We'll do this first one here will be a side angle angle here. Okay. So let's solve this triangle. Right off the bat, you're told that, and I've got the picture here, that angle A is 64 degrees, angle C is 82 degrees, and the length of C over here is 14 centimeters. All right, so it says round to the nearest tenth for all these problems here. All right, so to solve this, we need to find, here's what we need to find. We need to find the measure of angle B. Then we need to find the length of A and the length of B. Okay, the three missing things. All right, so the easiest one to find here first is the missing angle. Okay, so that's the easiest one to find first. All right, so look, we know that A plus B plus C has to be 180 degrees, okay? Well, look, we know A and we know C, okay? So 64 degrees plus B plus 82 degrees is equal to 180 degrees. So look, B here, if you just grab your calculator, really, you're just subtracting over, right? So you're gonna take 180, subtract away 82, subtract away 64, and you get this 34-degree angle, okay? All right, so now to solve for the lengths of A and B, you'll need the law of sines. All right, and I'm going to do that on the next slide here. And so here's what you're going to do here, all right? We know right off the bat, look, I know C and sine of C. So I'm going to use that to help me find A and B, okay? And it doesn't matter which one you do first. All right? So I'll put this here so we have it. So let's find A. So here's what we have. We have A over sine of A is equal to C over sine of C. All right, and so to solve for A, you're just gonna basically, multiply each side by sine of A. So A is equal to C C times sine of A divided by sine of C. Well, look, what is C? C is 14. Sine of 64 degrees, that's A, divided by sine of C, well, C here is 82 degrees. And when you go to grab, you're going to need your calculator here at this point, all right? Make sure your calculator, when you go to do this, is in degrees, okay? Because if you put in radians, you're going to get it wrong, okay? So make sure you're in degrees. So it's 14 times sine of 64 divided by sine of 82. And look, we're going to the nearest tenth. So what we're saying here is it's roughly 12.7. Now we can find B. So look, B divided by sine of B is equal to C divided by sine of C. So look, it's the same deal. Multiply each side by sine of B. So B is equal to C times sine of B divided by sine of C. So C is 14 centimeters. Sine of B, okay, so that again, sine of B here is 30 sine of 34 degrees, sorry about that. And C here is sine of 82 degrees. All right, let's grab our trusty calculator here. So this one is going to be 14 times sine of 34 divided by sine of 82. And look here, this is roughly 7.9 centimeters. And we got them. Okay, so look, this is what we started with. We wanted to find B. We got B. And then look, I just used the law of sines to find A and B. A is 12.7 centimeters. And B here is 7.9 centimeters. So we got it. We did it. All right, let's do another one here. All right, just, you know, so you can see, you're going to notice it's going to be the same procedure, okay? Same procedure. So here's an angle side case. So solving triangle ABC, if A, so A is right here, A is 40 degrees, and C here, sorry for all the coughing, everybody. Just that time of season when I'm recording this. Allergy season. Angle C is 22.5, and B is equal to 12. No units here, okay? So again, round to the nearest tenth. So what we're going to need to find here is we're going to need to find A and C and B, okay? So we need to find angle B and then the lengths of side A and C. All right, so the easiest one to start with is find the angle. So look, I've got 40 degrees. I'm going to find B plus 22.5 is equal to 180 degrees. So grab your trusty calculator here. 180 minus 40 minus 22.5. Okay. So here, you know, we have an obtuse angle. Okay, so it's 117.5 degrees. All right. Okay, now we're going to need to use the law of sine to find these lengths. Okay. So to find the lengths of the sides. No problem. No problem. Very, very easy to do. All right. So let's, you know what I would actually encourage you to do? I'm going to go to the next slide here. But, you know, I would encourage you to pause the video and try it on your own. See if you could, you know, see if you could do it. You know, if it helps, you know, just to see if you could find A and C here. So I'll be quiet for a second and then I'll show you how to do it. Well, hopefully you gave it a pause the video and gave it a shot. And then if not, if you just want to see me do it, that's okay too. All right, so let's do this. All right, so in here we have, this is 40 degrees, C was 22.5 degrees, and we saw that B was 117.5 degrees. So we want to find A and C. All right, let's find A first. So A over sine of A is equal to, well, I've got B and B here, so B over sine of B. All right, so finding A here, what's going on here is A is equal to B times sine of A over sine of B. So that's 12 times sine of 40 degrees. And B, so that it would be sine of 117.5 degrees. Trusty calculator. 12 times sine of 40 divided by sine of 115 or 117.5, excuse me. Well, look, when we round this up, we get roughly 8.7. All right, so that's A. Boom. So to find C, all right, I'm going to use B over sine of B is equal to C over sine of C. So then just to get B by itself, right, you know, you got C times sine of B all over sine of C. Oh, I'm sorry. I wanted to find B here. Or I wanted to find C here, sorry. solve for B. I was on autopilot a little bit there. Yeah, so just multiplying over here, sorry about that, you get C is equal to B times sine of C all over sine of B. Sorry about that. All right, well, B is 12. Sine of C, well, that's sine of 22.5. And then B was 117.5. So sine of 117.5. Sorry about that little error there. So let's grab our trusty calculator here. So 12 times sine of 22.5 divided by sine of 117.5. All right, you can see here roughly when I round it, I get 5.2 when I round it to the nearest tenth. So we got it. We got them all. All right, so those are cases that are like incredibly straightforward. So what I want to do is I want to just talk to you about the ambiguous cases here. Okay, when it's that side angle. All right, so this is the ambiguous case. So if you're given two sides of an angle opposite one of the two sides, so side angle, the given information may result in one triangle, two triangles, or no triangles at all. So side angle is known as the ambiguous case when using the law of sines, because the given information just you don't know what the right answer is, because it can result in one triangle, two triangles, or no triangles at all. Okay, so let's consider this one. Okay, consider a triangle in which A, B, and A are given. Okay, so here it turns out this will result in one triangle. It will get one triangle if A is greater than H and A is greater than B. So there's all these like additional requirements that you have to have here. And you can see here when I talk about the height, it's when you draw down to get a right triangle. Right? So you could use your right triangle trig to get the height here. So this is the case here where you get one triangle and it solves out and it works fine, and that's wonderful. All right. You can get one right triangle additionally too here if A is equal to the height, all right? And it's just you just really have a right triangle. All right, now what happens is you can actually have no triangle. And I'm going to work an example of this so you can see. So if the side A is less than H and it's not long enough to form a triangle, like there's no way you could draw it so that you get this, it forms a triangle. So you get this type of case. I'll show you that, and I'll show you how to recognize that when you solve. And then sometimes you get two triangles. And I'm going to show you an example of that. So if A is greater than H and A is less than B, you get two distinct triangles. Okay, you don't know which one though. This is one triangle here, and then this is the other triangle. So it's a little bit brutal, and I'll do an example of that so you can see it here. All right, so here'll be the first one. This is going to be an example so how you can recognize when you have no triangle. All right, so if you have triangle ABC, all right, if A is equal to 50 degrees and A is equal to 10 and B is equal to 20, okay, let's start off by finding, let's find angle B, okay? All right, so down here, okay? Well, look what you're given. You're given A and angle A, so we'd have A over sine of A. You're given B is equal to B times sine of B. All right, now remember what you want to find here. You want to find B, okay, angle B. So you cross multiply, you get A times sine of B is equal to B times sine of A. And then divide by A. So look, sine of B is equal to B times sine of A over A. Now watch what happens. I get 20 times sine of 50 degrees all over A, which is 10. And you might be like, okay, well, whatever, I'm solving. So 20 times sine of 50 divided by 10. Okay, hopefully, you recognize that this is an issue here. So I've got 1.53. So this is what I'm saying. Sine of b is equal to 1.53. Okay? But wait a second. What is the range of the sine function? It's between -1 and 1. All right? So there is no angle b for which the sine function is greater than 1. So right there, right off the bat, you should recognize, I got no solution. Okay, so the law of sine fails here. Okay. All right, doesn't work here because it turns out you didn't have enough information to show that this wasn't really a triangle. All right, the next case is the harder case. Okay, it's when you got two triangles, and I'm going to help you recognize when to see that. Okay. All right, so let's solve triangle ABC. If A is 35 degrees, okay, and A is equal to 12 and B is equal to 16. It says round the lengths of the sides to the nearest tenth and the angle measures to the nearest degree. Okay. So since you're given length of side A and the length of B, let's find sine of B here. Okay. So look, you're going to go 12 divided by sine of 35 degrees is equal to B, which is 16, over sine of B. So, you know what, just cross multiplying here, right? You get 12 times sine of B is equal to 16 times sine of 35 degrees. So sine of B is going to be 16 times sine of 35 degrees divided by 12. All right, well, let's see what we get. (16 times sine of 35 divided by 12. All right, so I get 0.6748 here, roughly. Okay, I'm going to round it off here. 0.6748. (0.7648). But now, so here's the thing, okay? Between 0 and 180 degrees, okay? Because remember, your angle here, going back for your triangles, right? Like, you know, when you set up the triangle, I didn't tell you if it's 3 acute angles or one obtuse angle here. So, like, what's going on here, and this is where it's difficult, between 180 degrees, sine of B is equal to 0.7648 two times. So like if you were to get, you know, B would be equal to sine inverse of 0.7648. So sine inverse of 0.7648. You get 49.89. Which would be roughly 50 degrees because we're rounding to the nearest degree. Sorry about that. Sorry about all the coughing. So what's going on here? That's only one of the two times. All right. Thus, the other time this happens, so B1 could be 50 degrees, and then the other possible angle would be 180 minus 50 degrees. So you have two cases here. So this is where it gets terrible with two cases. You have to solve both cases then, okay? Sorry about all the coughing again. So look, here's what you'd have to do, right? You know, one angle is 50 degrees. One is 130 degrees. You know angle A is 35 degrees. So then angle C, depending on what angle B was, could also be two different angles. So then you got to go through the case here of finding the lengths of the sides of C given the two different angles that it could possibly be with the two different angles B could possibly be. And it's like, ugh. And you can see here, and I'm not going to work through it, all right, you know, waste all the time here, but you can see that you're going to get, you know, different solutions, right? So this is the case where it's the ambiguous case. You just have to recognize when you solve here, okay? You know, between 0 and 180 degrees, you know, if you're given side angle, you're given side angle, you're going to get two cases here when you have a sign that's between -1 and 1. Or, well, in this case here, you know, between when it's between 0 and 1, more specifically. All right. Let's now talk about using kind of an application of this, a formula for finding the area of an oblique triangle. So the area of a triangle equals 1/2 the product of the length of the two sides times the sine of their included angle. Okay. So in the figure, this wording can be expressed as the following formulas. The area of an oblique triangle is equal to 1/2 B times C times sine of A, or you could have 1/2 AB times sine of C, or you could have 1/2 AC times sine of B. Any of these formulas would work. All right, let's put this to work here. All right, so let's find the area of the triangle having two sides here of length 8 and 12 and the included angle of 35 degrees, 135 degrees. Well, look, if you just set this up, this is B, this is A, okay? And you can see I'm telling you here angle C is 135 degrees. So you're given AB and angle C, AB, angle C. I can use this middle formula here. So the area is equal to 1/2 times AB times sine of C. So that's 1/2 times 8 meters times 12 meters times sine of 135 degrees. And rounding to the nearest meter, 8 times 12 times sine of 135 . You get 67.88 here. Oh, and I'm sorry, I forgot the 1/2. Ha! So, sorry, you get 34. I forgot the 1/2, so let me do that again. 1 divided by 2, forgot that, times 8 times 12 times sine of 135. That's two mistakes in this lecture here. There you go, 34 meters. All right, let's end now with an application problem, okay? And hopefully I won't make a mistake on this one here. And so for this problem here, what's really going to help is I'm going to draw a picture, and the picture is going to help us solve this, okay? So two fire lookout stations are 13 miles apart, okay? With station B directly east of station A. Okay, so if here's, the picture is this. If here's station A, 13 miles directly east is station B. Okay? And there's this fire, okay? And let's just, out here, we'll say here's the fire, okay? I don't know, whatever a fire looks like. Okay. Now this is where it gets weird. The bearing of the fire from station A is north 35 degrees east. So what that means is here's north, straight north. And then the angle from A to the fire, this angle here is 35 degrees. So this exterior angle here is 35. And the bearing from the fire of station B is north 49 degrees west. So here's north, and then we're 49 degrees west from north. So here's 49 degrees. How far to the nearest tenth of a mile is the fire from station B? So I want to find from here to here, like as the crow flies, how far? Well, look, here's C, okay? All right, this is going to be angle C. We know this is lowercase c, it's 13 miles. It's asking me to find B. Lowercase b, okay? So look, if this angle is 35 degrees, we know that this interior angle has to be 55 degrees, right? 90 minus 35, I'll get you 55. And then similarly, this angle in here is 41 degrees. So to find angle C, you would just go 180 minus 55 minus 41. And look, this angle here, boom, 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 is 84 degrees, angle C. So then look, you could just use this. B over sine of B, because I'm asking you to find that, is equal to C over sine of C. So solving, because we want to get B by itself, B is equal to C times sine of B over sine of C. Well, C is 13 miles. Okay. B here, okay, sine of B. B is 41 degrees. Divided by sine of C. What is C? C is 84 degrees. All right, let's grab our trusty calculator. 13 times, sine of 41 divided by sine of 84. And look, you're getting this to be roughly 8.6 miles. All right, class. You know, I did this mistake again, and I hope everybody caught it. I said I wouldn't make any mistakes. That's really funny. It's asking you to find A. I'm sorry. Because it's the distance here. It's asking you to find A. So even I set this up. Sorry about that. So it's A over sine of A is equal to B over sine of B. I did that on purpose to see, you know, what was happening here. So A is equal to B times sine of A all over sine of B. Sorry about that, everybody. I had my little letters mixed up here. So B here, okay, B, I'm gonna have to use C, sorry about that. Sorry about that. C times sine of A over sine of C. So yes, 13 times sine of sine of A here is 55 degrees over sine of C, which is 84 degrees. So 13 times sine of 55 degrees divided by sine of 84 degrees. Sorry about that. And you get 10.7 miles. And there you go. So just make sure, you know, a little bit, you can see here, even the teacher here is fallible on this stuff, right? Just make sure you remember A, B, B. Sorry about that. All right, class. You know, hopefully this lecture wasn't too bad, too confusing. And if you have any questions, you know, please let me know.